Okay, this is a demonstration of a 573A made by Dynatel, a 3M company. This unit is used to locate underground cables primarily, but it can be used to find underground gas pipes and water mains. It has several different modes of operation. It has an RF mode, and it has a couple of settings, a high and a low setting on the RF. And this puts out a 300 kilohertz pulsed signal. It puts out a whopping 200 volts, and it travels about a mile in length. There's also an audio setting on it, and it puts out a very high voltage audio signal through the direct line. You can't use the inductive mode for this, but you can use inductive mode on RF. When you put the direct cable in, you can tie directly to a conductor and transmit an audio signal down the line to find out where the cable is. You use this if you're locating more than a mile. The audio signal will travel a long way, several miles, and it has several different settings on it as well. It has 5 different settings. You can also use the transmitter here for locating faults in cables. If you have the insulator on the cable is broken and the conductors are exposed to earth, you can use the fault indicator here to find where the fault, well, not where, but you can determine there is a fault, and then you can use the receiver to find out where that fault is. Okay, I have the transmitter outside here. I have the direct connection, and I got a ground connection here with a screwdriver, and I got the other end on a conduit that's heading into the earth. I'm going to use RF mode here to try out the receiver. Okay, the receiver's got 3 modes of operation on it. As you can see here, it has an RF setting, audio, and a power cable detect. Now, the power cable detect, you don't need the transmitter. It picks up the 60 hertz current flowing in the cable if you're locating power cables. On this end, we got a settings. We have a null locate, and we have a peak locate, and we got a battery check here. It's got fresh batteries. Batteries are good. And then we got a set setting to find out the depth of the cable, and we also have the fault indication. This is where we use the A-frame to locate where the fault is. So the operation is very simple. I got the transmitter running up above about 100 feet in direct mode. So we know there's a cable here somewhere on the ground. So I put it on null. The null setting is the area between 2 peaks. You see I'm peaking here on the right, dead here, and peaks on the left. The cable lies right here, and we can also use the peak setting to find out where the cable is. The null is a much better way of locating exactly where the cable is. You can use the meter to pretty much find out where the cable is. If we want to find the depth of that cable, first we find exactly where the cable is again. So it's right here. We put this in set. We want to crank up the sensitivity till it's right where in the middle of the meter, where it says set. Then we turn it back to peak. And then we lift the receiver until it gets back in the middle again. And this is indicating about a 1 foot depth of the cable. Now if you want to use the triangulation method, you can do that as well. And what you do with this is you find exactly where the cable is. You would mark it here in the center. Then you turn the receiver at 45 degrees and you pull it away until the sound stops. This is telling me the cable's, again, about 1 foot distance. Now there's an audio setting here which I'll go into next. You put it on audio, you need to put the transmitter on audio as well, and you need to tie it directly to a conductor to do this. Hey, this is the operation of the passive mode in the 573A. You can see I have a power cable, a 200 amp power cable coming into the house here. You can see as I pass the receiver over the cable, you can see it peak. Kind of hard to see in this light, but it does peak over the cable. And the depth of that depends on the amount of current that's flowing in the wire. And this works pretty good. Okay, this is how the fault meter works. Right now I have a direct cable plugged into the direct output, and the cables are open right now. If I flip the knob to meter fault, you can see that it's showing that the cable is good, meaning the cable's open. So if I were to short the two leads together and do a fault meter test again, this should peg to the red, indicating there's a fault. In other words, there's a ground that's open, or there's a conductor open to the earth, and it's showing a fault. I've got an underground coax cable here. It's insulated, but it's got a crappy insulation on it. If I do a test on it, the other end is sticking out of the ground as well. And if I do a fault indicator on this, it's also showing right on the edge of fault and high resistance.